Hello. I'm going to work through the one of the examples in section 6 of chapter 6, area between two curves. How to find the area between two curves? This example is a application problem. So we need to convert the word problem in mathematical language first, but it turns out that this problem can be solved by using area between two curves. Okay, so what's the question? The question is Carl Williams, the proprietor of Carl Williams Auto Sales, estimates that with extensive television advertising, car sales over the next several years could be increasing at the rate of 5 times e to the 0.3 t thousand cars per year. T years from now, instead at the current rate of 5 plus 0.5 t to 3/2 thousand cars per year. And again, T years from now. So these are two different rate of change. If he changes the plan or he, put more advertising. So we need to find more cars. Carl expects to sell over the next 5 years by implanting his advertising plans. Okay. So we are given the rate of change, how many cars per year, the increase of sales. But these are two plans. With the current plan, the rate of change is 5 plus 0.5 t to 3/2 cars per year. That's the increase, the rate of increase of sale of cars. But if he implants the new, advertising scheme, the rate of change of sale will becomes 5e to the 0.3 t thousand cars per year. Okay, so these are two different rate of change. We can consider, there are two different functions, or if you plot the graph, these are two different curves. And we need to find, how many more cars he expects to sell over the next 5 years. If he implants the new plan. Now, the total number of sales of cars is the integral of the rate of change of sales. Okay, so that's the first thing we need to understand. So we need to integrate the rate of change to get the total sales in the next 5 years. So, but he has two plans. So the question is to ask, what's the difference between these two plans in terms of total sales in the next 5 years, right? So this actually converts to the problem of area between two curves. If you think the two rates as two curves or two functions, and then you integrate those two curves or two functions over the period from 0 to 5, in the next 5 years. So that's from 0 to 5. You actually obtain the area between the two curves. Okay. So that's the physical interpretation of this problem, and how we approach this problem. So anyway, the problem becomes mathematically we need to find the area between the two curves. So we can call one curve or one function f, for example, of t equals 5 plus 0.5 t to the 3/2. Okay, so that's the current rate of sale. Okay, and then the new plan, we can call it G. Okay, so it will give different rates of sale. So that'll be G, which is 5 times e to the 0.3 t. Okay, so now these are the two functions and the two curves. You graph them, and you know, we need to integrate, you know, the difference of those two functions. We try to find the area between the two curves. Okay, from 0 to 5. So the problem becomes the integral of f minus g, I mean g minus f actually, from 0 to 5. Okay, because we're trying to find the difference of the total sales in the next 5 years. So that's from 0 to 5 from now on. And the integral is g minus t. Okay, remember g is the new plan and f is the current plan. Okay, just this is integrated g minus f from 0 to 5. So in terms of area, that's the area between the two curves of f and the g from 0 to 5. Okay. So now let's just plug in everything in here and evaluate the integral. Well, g is 5 times e to the 3t, and f is just 5 plus 0.5 t to the 3 halves. Okay, so let me just put the parentheses in here inside. Well, come on. And then we can just integrate it term by term. It's not a difficult problem. So let me just copy the whole thing. So why don't we just distribute the negative sign in the second term. Okay, get everything anyway. Okay, so I just distribute the negative sign in the second term in integrand. So now, well, we just need to integrate each term by term. So one of the things we have to do is we have to use integration by substitution for the first term. Okay, so let's just do it in step by step. So let u equal to 0.3t. Okay, we know how to integrate 5 and t to the 3 halves. That's not a problem. But for the exponential function e to the 0.3t, we have to use the substitution here. It's not e to the t, it's e to the 3.3t. So we need to change the variable. Okay. So then, okay. Then what? Then we need to do du, right? Okay, so du, differential is just 0.3. Well, if we write all the steps, it will be the derivative of 0.3t. Remember the independent variable is t instead of x. So you can take out 0.3, so it becomes the derivative of t, which is 1. Okay, so just write all the steps in here. So we get a 0.3 times 1 times dt. Okay. Okay, so that's just 0.3 dt, right? The next thing I'm going to do is I'm going to divide by 0.3 on both sides of this equation, so that we can figure out, the what dt in terms of du. Okay, so we got du equals 0.3 dt. If we divide by 0.3 on both sides, we're going to get du over 0.3 equals dt. Or if you write dt on the left, okay, and du over 0.3 on the right, you get this. Just switch the size of, the terms to the other sides. Okay, so that's just the differential of u and t. Okay, and then if we are to use integrated by substitution, then we have to figure out the new lower and upper limits of integration. Okay, for definite integrals. So let's just figure out that first. So when t equals 0, that's low limits of integration for the original integral, and then u will be, okay, that's pretty simple. U equals 0.3t, so that's 3 times 0. So obviously that would be 0. Okay, so that's also 0, no problem. And when t equals 5, then u equals 0.3t, so that's 0.3 times 5. Okay, times 5, which is 1.5, isn't it? So that's 1.5. So these are the new upper and low limits of integration for u. Okay, so now we are ready to do the integral, the first integral actually in the original problem by using the substitution method. Okay, so let's just break up this integral into 3. Okay, I'm going to write 5 times e to the 0.3t, and then minus, okay, minus, 5 integrate 5, okay. 5 dt, so that's this second term, and then the other term is just the 0.5t to the 3/2. Well, I have to write the integral sign first, so let's just do it step by step. Okay, So we get 0.5 to the 3/2 dt from 0 to 5. Okay. So now, I guess I need to change the setting so that we can make the fonts a little larger. Okay. Anyway, let's just continue. Okay, so the first integral we can just do the substitution. Okay, so it becomes the integral of u, and u is from 0 to 1.5 in here, and then we get 5 times e to the 0.3t, but 3.3t is just u, so that's just e to the u. Okay, e to the u, and we got dt, which we can replace by du over 0.3. Okay, so that everything is in terms of u. So that's the first integral. We this using it quite some steps. Okay, and the second integral is just, we can take out the 5, and then it just dt, or 1 dt if you want. Okay, let me just write 1 here if you don't mind, so that you can see it clearly. And then we can take out 0.5 from the third integral, and we can integrate the whole thing. Okay, so now we can do the integral, one by one. Okay. Paragraph. We don't need single. Okay, we don't need let's just put 0 here. Okay, so that looks a little better. Everything is after is also 0. Okay, let's just see if we change anything. So it doesn't change anything here. Okay, let me just see if we can do. Okay, so this has to be 0. Change this to 0. So we have more space to work on, and we can see it more clearly. Okay. Okay, that's much better. And I want to also change this. So, okay. So now we can work out the problem. Oh wait. So, well, once again, we got 5 on 0.3. So, I guess I just take out 5, but at the same time we have 1 over 0.3, right? So that's times 1 over 0.3, not 3. I'm sorry. That will make a difference, a big difference. So then what's left? It's just e to the u. Well, okay, I don't know why. But Okay, so so we just integrate e to the u from 0 to 1.5, and then the next term, if we integrate 5 or 1, you get a t. So that's 5 times t, and you evaluate at 0 and 5 and they subtract. Okay, so let's just do that. So 0 and 5. Oh, come on. Okay, so I used the wrong notation here, so it should be it should be a bar, vertical bar. Okay, so this one. Okay, and then 2 box. So that's from 0 to 5. Let me just say wait. Okay, so that's the second term, and the third term minus 0.5 times what? T to the 3/2. So this is the power function with power with n equal to 3/2. So if you use the power roof integration, it should be t to the 3/2 plus 1 over 3/2 plus 1. Okay, so that will be equal to t to the 3 plus 1, 2 plus 1, and 3 halves plus 1. Okay, and once again, add it to that 5 and 0 and subtract. Okay, so we got these. So now we just plug in numbers and figure out the answer. Okay, so we can put 5, in the front if you think that's 501. So I'm not going to write it, but everybody knows what I mean. So that's 5 over 0.3. Okay, and then now we got e to the u. Okay, integrated e to the u over u, you get the e to the u, and then use the evaluate. And oh, I'm sorry. Wait. Evaluate this e to the u at 1.5 and 0 and subtract. Okay, so that's the first term, and then the second term we already LT. Oh wait. Okay. So minus 5 t divided by 5 and 0, and minus 5, and 3/2 plus 1 is just 5/2 if you rewrite 1 as 2/2. So you get 3 plus 2 on the top, and you keep 2 at the bottom. So I'm not going to write this again in detail. Okay. But we got t to the 5/2 at the end. Okay. And also the denominator should be also 5/2, and also evaluate it at 5 and 0 and subtract. Okay, so let's just do this lengthy thing, step by step. So we got 5 over 0.3 first term, and multiply e to the 1.5 minus e to the 0. Okay. Oh wait. So we got e to the 1.5 minus e to the 0. Okay, so if we plug in 1.5 and 0 for u and subtract them, that's the first term, and then we get a 5t. So plug in 5 for t and 0 for t. So that's 5 times 5 minus 5 times 0, right? Okay, 5t, 5 times 5, 5 times 0. And then minus, okay. So now we can, again, you can rewrite these fractions. But let me just combine these two steps in here. In the last term, I'm not going to write too many steps, but instead I'm going to write 0.5 over 5 over 2 and t to the 5 over 2. So that's multiply by 5 over 5 over 2. So multiply this number. Okay. Oh, sorry. 5 to the 5 over 2 minus, okay. Oh, so this is a lengthy process. Minus this coefficient in the 5 over 5 over 2 of the okay, so come on, why do we get this? Oh, I see. Times, okay, times 0 to the 5 over 2. Okay, so let me just copy that and change that to 0. But we know that will be 0 anyway. So that's the numbers. So now we just need to figure out the numbers. Okay, let's just simplify this thing a little bit. Okay, so let me just do it step by step, and then we can figure out the final answer at the end. So that's equal to 5 over 0.3 e to the 1.5 minus e to the 1, which is 1, e to 0, which is 1. Okay, so that's the first part, and then minus 5 times 0 is 0, so we got just 5 times 5, which is 25. And then minus, okay, now, so we got another number in here, but 0 to the 5 over 2 is just 0. Okay, so the second part or second term in the third part is just 0. So we need to only consider this term. We got 0.5 over 5 over 2. So 5 over 2 in the denominator, just 2.5. So we got 0.5 over 2.5, and you can reduce it as 1 over 5. That can be done easily if you check it yourself. So actually the coefficient for the third part is 1 over 5, and what we are left is just 5 to the 5 over 2. So times 5 to the 5 over 2. So at the end, if we use a calculator, to figure out those numbers, you're going to get 21.8. So that's in thousand. Okay, so what it means is if you apply the new plan, you're going to increase the sales of 21.8 thousand cars in the next 5 years. That's the final answer.